Incredible inventions you didn't know about. Number 8. Tyler. Tesla made Tyler, which is a system for charging light electric cars without wires. It's a system that's good for the climate and easy to use. Its main goal is to make sure that the infrastructure is strong enough to support the growth of light electric vehicles. The act of charging first, with the kickstand that Tyler gives you, you can charge your e-bike or any other small electric car. Tyler has raised a total of 1.3 million euros in funds and has its headquarters in the Dutch city of Delft, which is in the province of Zuid-Holland. There's a big chance that wireless charging will make having an electric vehicle more convenient, cost-effective, and appealing for drivers and fleet operators. Wireless charging systems like Wireless Energy Protocol, HOFA, Wave, and Magnet can be used to charge electric cars. Now, Tyler is the most well-known wireless charging methods that affect electric cars. Number 7. Flat Panel Haptics. Flat Panel Haptics, or FPH, is a relatively new method that uses integrated electro-osmotic pumps, or EEOPs, to make temporary pop-up buttons on OLED displays. Even though the technology isn't perfect yet, there's a reason to be hopeful about its future. The idea for flat panel haptics came from LCD flat panel visual displays, which have an actuator built right into a thin, small form factor and allow a voltage to be used to drive a display element. Flat panel haptics are thin and small, just like LCD screens. This method helps to reduce the size of the technology and improve the clarity of form display rendering. So it solves one of the 12 big problems with shape-changing interfaces that the HCI group has to deal with. The first tile that charges attaches to the kickstand of your e-bike or other small electric car and gives it power. FPH is a solution that's good for the environment and easy to use. It was made with the goal of providing an excellent infrastructure to help the market for light electric cars grow. Number 6. Wheelbot. Researchers at RWTH Aachen University, led by Professor Sebastian Trimp and the Max Planck Institute for Intelligent Systems, or MPIIS, in Stuttgart, recently built Wheelbot, a bicycle with a symmetric response wheel. Wheelbot is able to jump onto its wheels on its own from any starting point. The Wheelbot is a unique robot that was made by putting together parts that could be bought off the shelf and parts that were made with a 3D printer. It's a simple unicycle robot that roboticists and computer scientists from all over the world can use as a testing tool. A piece in IEEE Robotics and Automation Letters talked about the Wheelbot's mechanical and electrical design, as well as its estimation and control algorithms. Experiments that showed both self-erection and rejection of disturbances while balancing were also described. The Wheelbot is a hard place to study nonlinear control and control that's based on data. Even though the technology isn't perfect yet, there is reason to be hopeful about its future. Number 5. Jimu's Intelligent Parking Robots. Jimu's Intelligent Parking Robots is a system that tries to make parking lots grow in a way that has a perfect infrastructure. This solution is both easy to use and good for the world. The 4th version of the Jimu parking robot uses a new design that's been trademarked and has robot arms in the middle and differential driving units on the sides. The software and program have also been improved in a lot of ways to make them work better. Jimu's 2-piece parking robot had a unique design that let it go under the car, and its robot arms could be moved to fit the cars with different wheelbases and lengths of drive shafts. The Jimu parking robot can carry up to 2.3 tons of weight, which is enough to move the vast majority of passenger cars. There's no longer a need for extra tools like carrying boards, vehicle support frames, or combs. This will make remodeling the parking lot easier and cheaper. The Jimu parking robot uses technology that lets cars drive themselves to get exact indoor positioning, avoid obstacles, find its way around, and do other things. The ability of the robot management system to efficiently coordinate several robots through unified scheduling and optimal path planning makes a big difference in how well parking lots work and how much room they use. Number 4. XDR-80T-EAT. The XDR-80T-EAT is an electric mining truck that can drive itself. It was made by XCMG Machinery, a well-known Chinese company that makes building and mining equipment. The car has a variety of sensors, some of which are visual and audible, and some of which are laser radar, millimeter wave radar, and video. The design of the driverless XDR-80T-EAT electric mining truck allows for both remote control and full control by artificial intelligence. The working cab has been taken out of the design of this car completely. In the fully autonomous mode, AI technology can figure out where to go and how to get there based on the production schedule of the mine operation system. It also makes it possible for other pieces of tools, whether or not they are automated, to work together. The XDR-80TEAT is made to be used in open-pit mines where people don't work very often. It's meant to replace traditional mining trucks with a fleet of robotic vehicles. The XDR-80TEAT makes the mining industry smarter by using technologies like intelligent control, self-driving, and electric power only. Number 3. Spinal Armor. Spinal Armor is a back support device that can help relieve back pain, both short-term and long-term. It's a new and innovative option that's been approved by the FDA and can be paid for with money from FSA and HSA accounts. Spinal Armor is different from other back braces because it supports the back in a way that fits the person's need when they lift, move, stretch, bend, or walk. Also, it can help workers whose jobs require them to sit on hard surfaces like stools, office chairs, trucks, and forklifts keep up good posture. The ergonomic design of Spinal Armor will support and balance your back in a comfortable way. It also lets you move your back in all directions. The back support system lets you adjust the amount of lumbar support you get, which also makes it easier for you to stay busy. Spinal Armor is made of high-quality breathable materials that help keep sweat from building up on the skin of the user. The low-profile form can be hidden by clothes and is comfortable to wear and easy to put on and take off. The Spinal Armor back support system is a great choice for anyone who wants to ease back pain but doesn't want to give up their busy lives. Number 2. Joy Rider. The Joy Rider is a brand new groundbreaking product that was made to provide a way to get around cities that's good for the environment and easy to use. It's a type of electric skate that allows you to control it by tapping your feet on the ground. The Joy Rider, which is the smartest pair of electric skates in the world and was made by a Chinese company called Passion Mobility, is designed to make life easier and smarter while lowering carbon emissions. With the Joy Rider, you can say goodbye to traffic, wait times, and uncertainty. It's a unique electric skate made for city travel that lets you get around quickly and easily. These are the first electric skates ever made that don't have any kind of remote handset. The Joy Rider has cutting-edge sensor fusion technology that lets users control the speed and mode with a simple tap of their foot. With a maximum range of 20 kilometers and a top speed of 20 kilometers per hour, the Joy Ride is great for short trips around town. If you want to find a new and fun way to get around the city, you should definitely think about buying a Joy Rider. Number 1. Tactile Fingers. Tactile fingers are a new type of robotic fingers that can feel what's being touched. Researchers at Columbia Engineering have made a new kind of robotic finger that can feel very accurately on surfaces that are both complicated and have many curves. Their finger can pinpoint touch with an accuracy of less than 1 millimeter over a large curved surface, just like a human finger can. The team from Columbia Engineering came up with a revolutionary plan that used overlapping signals from light emitters and receivers that were inserted in a transparent waveguide layer that covered the functional parts of the finger. By watching how light moves between each emitter and sensor, they showed that they could get a very rich set of signal data. The signal data set changes based on how the finger changes shape when it touches something. They got information like where the touch was and how much force was used. Their final result is a fully integrated robot finger with sensors that has a low number of wires, was made with easy-to-use manufacturing technologies, and was made to be easy to put into hands with good dexterity. Thanks for watching this video.